Hey everyone, a very good morning. I welcome you all to this breakout session. Today I'm going to talk about multi-stage YAML pipelines with Azure DevOps. Regardless of your experience with YAML pipelines, you will find this session useful. The session is going to be around 45 minutes long, and I would be covering my presentation for first 35 minutes, having the last 10 minutes for Q&A. If you get a question or a comment, please post it on the chat window, and I will get back to those at the end of the presentation. If you would like to talk to me later, you can find me at my employer's booth in the sponsors lobby. Let me introduce myself. My name is Vaibhav Gujral. I am based out of Omaha, Nebraska, and currently working for Kivit as a cloud architect. I'm a Microsoft Azure MVP and a Microsoft certified trainer. I'm a Microsoft certified Azure Solutions Architect expert, and I also hold few other certifications. I also run Omaha Azure User Group, which is a community of close to 900 people. I'm a regular speaker at several user groups and events, often speaking on Azure related topics. I also blog on vaibhavgujral.com. You can follow me on Twitter or connect with me over LinkedIn. Without further ado, let's jump onto agenda and see what we are going to talk in today's session. We will start the conversation around Azure pipelines. Then we will talk about the YAML schema, different components that go into the YAML schema like the triggers, stages, jobs, tasks, and so on. I will be demonstrating how to create multi-stage pipelines, and I will conclude the presentation with some of the differences between YAML and the classic pipelines. Let's start with Azure DevOps. If you have not used it in the past, for your benefit, Azure DevOps enables teams to plan, work, collaborate on code development, and build and deploy applications. The product has gone several rebrandings. It was originally called as Visual Studio Online. Then it was rebranded as Visual Studio Team Services or VSTS. Azure DevOps has its roots in traditional Team Foundation Server or TFS. In fact, the current version of TFS Server has been rebranded as Azure DevOps Server, which can be hosted on-prem. Azure DevOps offers rich features like Azure Repos for source control. You can either opt for Git repos or Team Foundation version control. Azure Pipelines support continuous integration and delivery of applications. Azure Boards offer a suite of agile tools to support planning and tracking work, code defects, and bugs using agile methodologies like Kanban or Scrum. Azure Test Plans offer several tools to test your applications, and Azure Artifacts enable teams to share NuGet, NPM, and Maven packages from public and private sources and integrate package sharing into your pipelines. It also offers some out-of-the-box features like dashboards, wikis, and notifications. You can also add extensions in your Azure DevOps environment through Marketplace. Overall, it does offer a great set of features and a platform for team collaboration. Today, we are going to talk about Azure Pipelines. Before we talk about Azure Pipelines, let's talk about continuous integration and continuous delivery. Continuous integration refers to the process of constantly and consistently testing and building code at every check-in, and continuous delivery refers to the process of shipping the code regularly to any target. Continuous integration includes stages like building and testing, whereas continuous delivery includes release and deploy stages. Overall, these two different processes of building and testing code and deploying and releasing code are referred together as CI/CD or continuous integration, continuous delivery. Continuous integration helps in increasing code coverage in your projects, helps you ensure that the code is not broken with every code check-in. You can run tests continually on your code as part of the CI process. Likewise, continuous delivery enables you to deploy your code to production automatically on triggers like whenever a new artifact is available. It helps you to ensure that all the deployment targets have the latest code which has been tested earlier in the CI process. Azure Pipelines is a cloud service that offers continuous integration and continuous delivery features to consistently test and build code and ship it to any target. Azure Pipelines can be created using two ways: classic user interface and YAML syntax. Azure Pipelines supports several programming languages and application project types like Python, Java, JavaScript, PHP, Ruby, C#, C++, and Go. Azure Pipelines supports Microsoft-hosted as well as self-hosted pipeline agents, including Windows, Linux, and Mac OS. Azure Pipelines supports deployment to multiple targets, including Azure on-prem and so on. Lastly, Azure Pipelines also supports NuGet, NPM, and Maven package formats. As I have mentioned in the earlier slide, there are two different models using which we can define an Azure pipeline. Starting with the classic model, we can define two different pipelines known as builds and releases. Builds are used for continuous integration where code can be built and tested and an artifact is produced as the outcome of the build process. The artifact triggers the release process, which picks up the artifact and deploys it to the appropriate targets. When using YAML pipelines, the build and release stages are combined together in a YAML file called as Azure Pipelines.yaml. One primary benefit that you get out of this approach is that you can define your pipeline as code and commit the pipeline code along with other code changes. Once the code changes are pushed into the repo, an Azure pipeline based on the YAML file gets triggered, which then executes CI/CD steps to build and test the code and deploy it to the target. Let's explore more on YAML-based pipelines. And before we actually talk about pipelines, let's talk about YAML. When I heard about YAML, I thought it would be another markup language, but I was wrong. It's not a markup language because it doesn't include any markup. Head out to yaml.org if you are interested in learning more about YAML schema. As per the website, YAML is defined as a human-readable data serialization standard, which uses positioning in simple characters as delimiters, as depicted in the example. As you can see, the structure is defined by indentation. Different key value pairs under the section YAML resources are separated by colon. Do note that string values in YAML do not require quotes. Lastly, if you will notice in the example under the list of projects, the list items are indicated with hyphens. Let's talk through the workflow of a YAML-based Azure pipeline. To start with, each YAML pipeline needs a trigger to get initiated. Within a pipeline, there could be one or more stages. Each stage is a way of organizing jobs in a pipeline, and each stage can have one or more jobs. Each job, in turn, can contain one or more steps. Steps can be a task or script and is the smallest building block of a pipeline. A task could be anything that performs an action, such as invoking a REST API or publishing an artifact. An artifact, in turn, is a collection of files or packages published by a pipeline run. You can have either agent-based jobs which run on an agent, or they could also be agentless. Azure DevOps offers many built-in tasks, and many more are available on Marketplace. Let's talk about triggers. A trigger is the initiation point for a pipeline. A trigger is an event or action that initiates an Azure pipeline to run. It could just be as simple as a code check-in. We can categorize triggers into four broad categories. The first one being the continuous integration trigger, which gets triggered whenever a code change is pushed into a branch in the repo. Then the pull request trigger is triggered when there is a pull request being approved. We can also schedule an Azure pipeline to run at regular intervals using schedule triggers. Lastly, we can also trigger a pipeline based on the completed run of another pipeline. We will talk about each of these trigger types in the next few slides. In case we don't want the pipeline to be triggered by any of these triggers, and we want to manually trigger the pipeline as and when we need, we can set the trigger to none. Let's talk more about continuous integration triggers. CI triggers are triggered whenever an update is either pushed to a specific branch or specific tags are pushed. You can control which branches get CI triggers with a simple syntax. You can specify the full name of the branch, for example, master, or you can use a wildcard. Let's talk through some examples. In the first one, the pipeline will be triggered if a change is pushed to master or to any release branch. However, it won't be triggered if a change is made to a releases branch that has old as a prefix in the name. If you specify an exclude clause without an include clause, then it is equivalent to specifying wildcard in the include clause. As visible in the second example, you can also configure triggers based on tags. If you don't specify any triggers, it utilizes the default implicit trigger as shown in the last example, where everything is included. When you specify a trigger, Azure Pipelines automatically replace the default implicit trigger with the branches that are included. If you are in a team where there are many developers who push code changes simultaneously, you can opt for batching, which keeps the system on hold until a run is completed. And once the current run is completed, it starts another run with all the changes that have not been built yet. Let's talk about the first example. If pipeline is already running for a code change that was pushed, till the time that pipeline is running, any additional code changes in the repo or included branch do not start new independent runs. But after the first run is completed, all commits until that point of time are batched together and a new run is started. You can also include or exclude specific file paths from the trigger. Like if I do not intend to trigger the pipeline every time I update my markdown file for my project, I can exclude the markdown file from the trigger as depicted in the second example. Do note that you cannot directly provide the path filter here. You need to provide the branch first and then the files that you would like to include or exclude. If you don't include any path filter, then the root path is automatically included. Do note that the paths are case sensitive in Git, so you need to provide the file names in the right casing. Lastly, you can also include and exclude tags, and you can use wildcards in conjunction with the tags. We can also use pull request triggers to run our pipeline whenever a pull request is opened with one of the specific target branches or when changes are pushed to such a pull request. To configure a pull request trigger, choose your branch and head out to the branch policies and choose the pipeline you would like to trigger under the build validation section. Schedule triggers cause a pipeline to run on a schedule defined using cron syntax. In this example, it is scheduling two pipelines, one running every midnight and one running every Sunday. Note that the time zone for the cron syntax should be in UTC. You need to explicitly specify the branches that needs to be included first and then specify the branches you would like to exclude. If you will simply provide the excluded branches and not specify the included branches, it won't build any branch. You can also trigger a pipeline once another pipeline completes its run. In this example, security lib pipeline is triggered once security lib CI completes its run. Like other triggers, you can include or exclude branches that you would like to build. Let's talk about stages. The first building block in any Azure pipeline is a stage, which is used to organize jobs in a pipeline and can have one or more jobs. A pipeline can have one or more stages. What you see here in this slide is the complete syntax for a stage. The first thing you define is stages, which is a collection of different stages in your pipeline. Then you have each stage defined starting with the name of the stage and a friendly name for it. If your stage depends upon another stage to run, you can define that under depends on section. We will touch that in the next slide. Likewise, if you want to control your stage run based on a condition, you can define that under the condition section. You can also define the pool of agents on which you want to run your stage. You can define variables here that you intend to use inside your jobs. And then in the last section around jobs is where you define the actual work that needs to be done in your stage. Whether it is building the code or deploying the app, it goes inside a job. Under job section, you can have one job or you can have a series of jobs depending upon what you are doing. We will look into the schema for a job shortly. As I mentioned in the last slide, you can create dependencies between your stages using depends on section. In the example, there is a stage called build, which is not dependent on any other stages. Then we have the stage called test, which is dependent on the build stage to complete its run. And then once the test stage completes, we have another stage called as deploy US, which is dependent on test. Lastly, the stage deploy Europe is dependent on both test stage and deploy US stage and is only run when test and deploy US stages complete their runs. You can also utilize conditions under which each stage runs. In the second example, test stage only runs when build stage is succeeded. Deploy US stage is only run when test is succeeded. Lastly, if deploy US stage fails, the deploy Europe stage is run. Note that we can use depends on and conditions together. Here, deploy US stage is dependent on the previous three stages and is only run when the last stage, deploy US, fails. Let's talk about jobs and agents. Now, a stage is a collection of jobs. A job in Azure Pipeline is a collection of one or more steps. Every pipeline has at least one job. A job is the smallest unit of work that can be scheduled to run. What you see here is the complete syntax for a job inside a pipeline. Starting with the very top, when creating a job, we need to start with a name and a friendly name of the job. Just like stages, we can utilize depends on and conditions to control the execution of jobs. You can also define a strategy for job execution. Continue on error allows you to specify if job failure will result in the pipeline failure. Sometimes the jobs can go unresponsive or takes too long to finish. In such situations, it is useful to define timeout setting in minutes. Jobs can be categorized into three buckets based on where they are run. Agent pool jobs are run on an agent in an agent pool. Server jobs run on an Azure DevOps server. Container jobs run in a container on an agent. As I mentioned earlier, that each job can be an agent-based job, meaning they can run on an agent. So the question that many people might have is what an agent is. Well, an agent is an installable software that runs one job at a time. There are two types of agents, self-hosted or Microsoft hosted. As the name suggests for both of them, the self-hosted agents are owned and managed by customers. It does comes with an overhead of management, but it does gives more control to manage the agents. It is extremely handy in situations where we need to install custom packages for build and deployments. Microsoft hosted agents are provided by Microsoft. They are essentially Azure virtual machines which run the agents on top of them. Since these are hosted by Microsoft, the maintenance and upgrades is their responsibility. There is a predefined agent pool available in Azure DevOps that has the Microsoft hosted agents. Both type of agents support Windows, Linux, and Mac OS as the operating system. Similar to stages as I mentioned earlier, we can also define dependencies between multiple jobs using depends on section. What you see on the left side of the screen is how we can execute jobs in sequence. As you can see, the second job release depends on the first job debug to complete. On the right side, you can see the different jobs which are executed in parallel. If you remember, I mentioned earlier that a job could be run on an agent or it could be an agentless job. If it's an agent-hosted job, we can run multiple jobs in parallel on different agents. Do note that each agent can run only one job at a time. To run multiple jobs in parallel, we must configure multiple agents. Using depends on section, we can implement patterns like fan out and fan in our jobs. On the left side, you can see a simplified implementation of fan out, where we have an initial job which is independent, and then we have subsequent jobs A and B which are dependent on the initial job. On the right side, you can see a simplified implementation of fan-in pattern. We have two jobs, initial A and initial B, which are independent. Then we have a subsequent job, which is dependent on both initial A and initial B job. Similar to stage, we can utilize conditions to control how our jobs run. There are some built-in job status check functions that you can utilize in your conditions like failed or succeeded. Check out the link listed there for the list of those functions. What you are seeing here is that job B depends on job A to complete its run, and job B is only executed when job A fails. Likewise, job C is dependent on job A and B and is only executed when job B successfully completes its run. It's not only the job status functions, you can use custom conditions as well using the different functions in expressions like equals, contains, ends with, and so on. Check out the list of the supported functions in the link listed over there. In the screenshot, what you can notice is the condition for job B, which is dependent on successful completion of job A, and also if the source branch is the master branch. If the pipeline is ran for any other branch, the job fails. Simple but super powerful concept to control the flow of your pipelines. When I was talking about the job schema a few slides earlier, I did mention about the strategy that can be defined for a job. From a single job, you can run multiple jobs on multiple agents in parallel. There are two different options that you can choose from. The first one is called metric strategy, through which you can enable a job to be dispatched multiple times with different variable sets. Whereas under parallel strategy, you can enable a job to be duplicated many times. When you follow the metric strategy, you shall specify the maxParallel tag to represent the number of jobs you intend to run in parallel. What you see in the example is the job called as test will be dispatched 3 times with the value of location and browser. However, only 2 jobs will run at the same time because we have set maxParallel to 2. Under parallel strategy, you need to specify the parallel tag intending the number of parallel jobs that needs to be created. Under parallel strategy, Azure Pipelines automatically connect two variables to each job, system.jobPosition in phase and system.totaljobs in phase. In the example, the job will be dispatched 5 times with the values of system.jobPosition in phase and system.totaljobs in phase set appropriately. If you intend to deploy through your Azure DevOps pipeline, then instead of using standard jobs, you can use a special type of job called as deployment jobs. What you see on the right is the schema for a deployment job. Like the normal job, deployment jobs also have properties like name, display name, depends on, and conditions. There are two main benefits that you get out of using deployment jobs over the normal jobs. Deployment jobs maintain deployment history, giving you insights into the status of your deployments for auditing. And you can also define the deployment strategy for your application. Currently, it supports run once, rolling, and canary strategies. Let's talk about tasks. Tasks are the building blocks of a YAML pipeline and are the actual execution units within a pipeline. Within a task, you define the actual work that needs to be done in your pipeline. It could be to build, test, or deploy your code, download or publish an artifact, call a REST API, or even execute a script. A job is made up of one or more tasks. Similar to stages and jobs, you can define different properties for your task in the YAML, like the name, the display name, condition, and so on. You can also leverage countless built-in tasks available in Azure DevOps. Chances are, for most of the common use cases like building and deploying code, publishing artifact, and so on, you will already have a built-in task. If there is no built-in task for your use case, you can also check out third-party tasks in Azure DevOps Marketplace. The last concept that I want to touch upon before jumping onto a demo is templates. Templates lets you define reusable content, logic, and parameters. You can use templates in your pipelines in two ways: to insert reusable content and to control what is allowed in a pipeline. If you use a template to include content, it behaves like an include directive in many programming languages. When you are using a template to control what is allowed in a pipeline, the template defines the logic that pipeline must follow. What you see as an example here is on the left side, we have a template where we are specifying a parameter called yes, no in the template file. We have our main Azure pipeline on the right where we are specifying the template and passing the value of yes, no variable in the actual pipeline. It's a very powerful feature and is currently only available in YAML pipelines and not in the classic ones. Check out the link listed down there for more details on templates. Enough of talking, let's jump onto a real demo and see how we can build multi-stage pipelines in Azure DevOps. I have created a new Azure DevOps organization for this demo, and I have named it SDC 2020. Under the organization, I have created a project called Parts Unlimited through Azure DevOps Demo Generator. You can also do so by signing in into Azure DevOps Demo Generator and then going into choosing template. For this demo, I have used Parts Unlimited YAML template. You can select that. You can choose your appropriate organization, give it a project name, and if you will click on Create Project, it will create the project in your Azure DevOps organization. I have also created a service connection under my project. to connect to my Azure subscription. In my Azure subscription, I have created two different environments, one for dev environment with all the dev resources, including web application and a SQL database. Likewise, my production resource groups contains a web application and a SQL database. I will go to the pipelines. The project comes with a base pipeline, which I can go ahead and use to deploy my code from my repo to any Azure web app. It's a YAML-based pipeline. As I was mentioning in my presentation, the first step in a pipeline is a trigger. For this particular pipeline, it gets triggered whenever there is a code change that is checked in into the master branch. It is using the pool agent image of Windows Server 2016. Here are some variables that it is taking in the pipeline. And here are the different tasks that it is doing within the job. It is restoring the NuGet packages, then building and testing my code, and then deploying it into Azure. Now you will see it doesn't have a web app name and a connected service name. I'll go ahead and configure that. I will utilize the service connection that I have created upfront for the deployment. I'll go ahead and choose the dev web app for deploying the code to that app service. I'll click on add. The moment I click on add, it will automatically update my YAML file. At this moment, it is not a multi-stage pipeline. It's a single stage YAML pipeline where it has a single stage and a single job, and the single job has multiple tasks. I'm going to go ahead and click on save. Since this is a CI trigger on my master branch, the moment I will go ahead and click on save, it will create a new run for my pipeline. I've clicked on save. I will go back to the pipelines here. And as I said, it has triggered one new run for me. As I can see, my pipeline has a single stage at this moment, which has a single job. And within that job, there are multiple tasks that my pipeline is going to execute. It is going to take a minute or so. The pipeline has run successfully. And as expected, it has deployed my application into the Azure. Let me go ahead and pull up my dev web app and see if it has the changes. I'll go ahead and click on the URL. And here is my app running in Azure, which I have just published through my Azure pipeline. Let me go back to my pipeline definition. Let me convert it into a multi-stage pipeline now. I already have the code for that, which I have prepared upfront before the demo. What I'm doing in this pipeline now is I have broken down my pipeline into two stages. The first stage is build stage, which is right here. And the second stage is deploy, which is right here. As the name suggests, the build stage is going to build and test the project, and deploy stage is going to deploy my application to Azure. I'm going to click save here. As you can see here, now it is a two-stage pipeline. If I go back here and come from here, looks like I have clicked save twice. I'll cancel the second run because my first run is good enough for the demo. So as you can see, there are two stages in my pipeline now, build and deploy. Build builds my project, and deploy deploys the application to the Azure. My pipeline run has completed. If I click on that, I can see that my application has been deployed, and in the build stage, it was built successfully. I'll go back into my pipeline definition now. Now, in most of the enterprises, there is not just single environment. There are multiple environments where the applications might run. So what I'm going to do next is I'm going to create two different environments for my application. And then I'm going to update my pipeline so that it can deploy my application into a dev environment and a prod environment. So before I can update my pipeline, let me go first and create two environments. I'll click on Environment tab. I'll go ahead and click on Create Environment. The first environment I will create is Dev. The second environment I'm going to create is called as Prod. I don't care if someone pushes any code in Dev, but for Prod, I want an approval mechanism in between. I'm going to add an approval gate. There are many different options that you can add in your pipelines. For now, I'm just going to add an approval. I would be the approver for the pipeline. I've added the approval gate. and I have added two environments, dev and prod. Next, I will go to the pipeline and update my pipelines to use environments. I'll go ahead and update the pipeline. Now you can see I have now converted my pipeline from 2 stages to 3 stages. My first stage still remains build. My second stage is deploy to dev, and my third stage is deploy to prod. As you can see, I'm setting my environment as prod for the third stage, and I'm setting environment as dev for my second stage. I'll go ahead and click on save, and let's see how the pipeline goes. As you can see here, from my 2 stages, now my pipeline shows it has 3 stages. If I click on that, it has now 3 stages. The first stage is build, the second stage is deploy to dev, and the third stage is deploy to prod. It will take a minute or so before it completes the deployment to dev, and it will stop at the approval check for the deployment to production stage. The deployment to dev has been completed, and as expected, before deploying to production, it is waiting for my approval. I'll go ahead and click on review. I'll provide a comment and click on approve. Based on the approval, it will go ahead and deploy the application to the production application in Azure as well. As you can see, it says one check passed. When I click on that, it says who was the approver and what was the check that was completed. I will give it a minute or two before it completes the deployment to production. The deployment to production is complete. I can see the task was completed. I will go to the Azure portal to validate that my code has been deployed. I'll go to the web application and click on the URL. Here is my web application that just got deployed to production. I will go back to my pipeline now and click on edit. Now, if you will notice here that there has been some redundancy in my pipeline. For example, the deploy to dev stage and the deploy to prod stage has the same task, but they are just executing it for different environment. So in that scenario, I'm going to utilize templates so that I can reuse my code across the different stages. Before I can go ahead and edit my pipeline, I'm going to go into the repo and I'm going to upload a file here for my template. I'm going to upload file. I'm going to browse here and I'm going to upload the template file and click on commit. I will go ahead and cancel the pipeline because it won't make any difference. I'll cancel this particular run. I will go back to repos to show you what's in there in the template. So basically, I have captured all these steps from the pipeline and put it into the template. Next, I'm going to go into my pipeline and update my pipeline to utilize the template. So here's the code for my pipeline to utilize template. So instead of calling individual tasks, it now calls a template which I have just committed into my repo. Same with the stage deploy to dev. It utilizes a template I have just uploaded. I'm passing 3 parameters to that: a service connection, an environment name, and the website name. And you can also see that how to use depends on and conditions here. So my deploy to dev stage depends on build stage, and it will only execute if build is successful. If the build stage fails, the deploy to dev stage will never get executed. Likewise, my deploy to prod stage depends upon deploy to dev stage, and if deploy to dev stage is not successful, deploy to prod stage will not be executed. With that, let me go ahead and click on save and see how it goes. I'll go into the pipeline. It says there is an error. Let me go ahead and see. It says it's an invalid name. Let me go ahead and fix it. It was an issue with the job name, which I have just fixed, and my pipeline is all good to go and it's running. Let's see how it goes. And the deployment through the template is done in dev environment and is waiting for my approval in production. I will go ahead and click approve. And let's see if it works for production as well or not. And the deployment to production is also complete using templates. In the beginning of this talk, I did mention that there are two different ways to create Azure pipelines. The first one is the classic UI-based pipeline, which comes with different build and release pipelines, and the second option being the YAML pipelines, which we have talked about in this session. If you have been using Azure pipelines or if you intend to use it in the future, there are few things to consider while making a choice. First of all, based on how classic and YAML pipelines work, there is a difference between the feature set available under both options. For example, container jobs are supported in YAML but not in classic. Task groups are supported in classic but not in YAML. Templates are supported only in YAML and not in classic. Check out the link I have posted down below for feature comparison between the two options. Microsoft has not published the roadmap for classic pipelines yet, but my recommendation is to use YAML for the new pipelines. If you already have classic pipelines and you wish to migrate classic pipelines to YAML, Microsoft might release something in future, but at this moment there is no direct way to do it. Lastly, the primary benefit you get out of using YAML pipelines is the version control of your pipelines. You can store the YAML-based pipeline files with your other code files and apply the same set of policies. Here are some of the resources you can use for your own learning. If you need more information on YAML, check out yaml.org. I have provided a couple of links for Azure pipelines. The first one provides an overview of Azure pipelines, and the other one provides an overview of YAML schema. I have also provided a link for Azure DevOps demo generator that I have used in the demo earlier. With that, I conclude my presentation, and I would like to open the floor for any questions that you might have. Everyone, with that, my presentation is concluded. If you have any questions, you can post it on the chat and I can answer that. Otherwise, I will be available on the booth for my employer in these expo booths. You can come and ask questions there. And Chandrakant did ask one of the questions around how to do file transformations for different platforms. Well, there are different file transformation tasks available within Azure DevOps that you can utilize for that purpose. I can probably post a link to the existing built-in task if I can find one. I guess that will be helpful. If no other questions, I would like to thank all for joining this breakout session.